Hello. Thank you all for coming and giving me some number of minutes of your lives.
You're welcome, Superman.
Have you ever seen the thing of your whole life measured in weeks in like one chart? It's awful. All right, today I'm going to talk to you all about stateless Ethereum. This is the best thing happening that I'm working on. I don't know. That's not the right direction. There we go. Woohoo! I am Piper Merriam. I work for the Ethereum Foundation. I run a team of Python engineers. We call ourselves the Snake Charmers. This is Snaky McSnakeface. You can find me on the internet here. Everything I do is open source. Everything my team does is open source. It's pretty cool. All right, high-level overview. At the end of this talk, you should all understand at a high level what we're doing, why we're doing it, all of these things. And you should probably have some questions because I'm not going deep here. I'm trying to give you the 1,000-foot view while diving in here and there, but to give you a very good picture of why we're doing this, these questions. All right, so when I talk about stateless Ethereum, we need to define what we mean by state. I think a lot of people in this room know this, but I'm going to go through it. Okay, so here's the state. We have, for every address, account, contract, whatever you want to call them in the Ethereum blockchain, we have these values, a balance, how much Ether do you have, some code if you happen to be a contract. Are there any contracts in this room? We've got storage, things like that for your fancy token balances, and we put these into a tree, sometimes called a trie, and this is what we call the Ethereum state. We have this fancy cryptography thing called a state root that lets us refer to this using a very small amount of data to refer to a very big amount of data. In the blockchain, we have blocks. Blocks are made up of transactions, and transactions modify the state. Here we have a block with a transaction where Alice sends Bob 1 Ether. When we execute this block, we change some of the state. Alice's account has 1 Ether deducted. Bob's account has 1 Ether added. Voila, we have executed this transaction and done a state transition. We've modified the state. So we have this concept of a witness, and a witness is sort of the subset of the state, the minimal subset of the state that we need to be able to do some sort of state transition. We call it a witness instead of calling it data because it's sort of like a more official piece of data, because it isn't data that you have to trust. It's data that if you have the state root, or if you know what the state root is supposed to be, when somebody hands you this data, you can prove for yourself. You don't have to trust them. You can prove for yourself that it is the right data, that it's the appropriate data. So Alice can't lie about her account balance in a proper witness. So when we talk about stateful clients and stateless clients, we'll treat this sort of as a binary choice right now. Stateful clients have a state database that has the entire state tree, all of the data in it. And stateless clients really just use sort of this concept of a witness, a minimal subset. So they use the witness as their database. We'll talk about a little bit about where does the witness come from and how do they get this. But for now, it's not super important. The idea, the high level idea is important. Stateless means that they don't have a full database of the state, but the cool part is they can there's no security trade-off here in the sense of both of these types of clients are still verifying the data in the same way, which is a pretty powerful concept. We'll get there. So when I talk about stateless Ethereum, what I am talking about is a broad effort that's happening right now with a large group of people across many different client teams and organizations to modify the Ethereum protocol as a whole to support this type of client in a very first-class way. So we want to make it possible to run stateless clients on the Ethereum network in a very efficient way, and we have some good reasons for doing that. And there are some really good extra things that we get by doing that. And that's a lot of what we're going to talk about today. Who is working on this? Here's a slide with some teams and things on them. This is not a complete list. I'm slowly building this slide out. But what I want to point out is that this is not like an Ethereum Foundation effort. This is not an effort by the Go team or the Trinity team. This is a very broad cross-organizational effort that's happening, involving a very significant slice of sort of if you want to call it the core development community or whatever. it's cool to see this level of broad collaboration happen. This was largely inspired by the collaboration that's happening in the ETH2 ecosystem. You have, like, what do we have? Anybody 6, 7 ETH2 clients? I don't know. But like, they all are getting like together and working together in this like really cool way to collaborate on a spec. And I said we should do that in ETH1, and so we kind of are. Okay, so like, why are we doing this? This is the business model of Ethereum. Pay once, store forever. There are no economic incentives in the Ethereum network to limit the overall size of the state. The logical kind of train you can follow here is that the state growth is unbounded, which means you will need bigger and bigger hardware to run a client if you have to have all of it, which means people are lazy and fewer people will run nodes, only those that have a strong enough incentive to overcome that kind of hill that you have to get over, which means that we will have a further and increased dependency on centralized providers. It's not so bad today. We've got like a couple of thousand full nodes on the network. But it could be way better. State rent, that's like a year and a half ago. I really like this guy. He's like really excited. Well, and this girl, like somebody may have farted near her or something. So like state rent was this like thing to try to fix this fundamental problem of state growth a little while back. Some of you may have been part of that or remember it. It ultimately didn't go anywhere, and my opinion as to why is that it was a really hard pill to swallow. It was addressing this and fixing it at a fundamental level by adding an economic bound to the overall size of the state by requiring people to pay ongoing rent in order to store things on the blockchain. Ultimately, this fundamentally changes the paradigm of smart contract development. There did not appear to be any way to do this without making a very non-trivial backwards incompatible change to the EVM, which, as we've maybe seen before, could lead to a contentious hard fork. I set my magic clicker down. So this didn't go anywhere. Now we're doing something different. We call it Stateless Ethereum. So how are we going to do this? This is probably the lightest part of this talk. I'm not going to get into details, but this is the part that I would love to talk to you guys after. And there are 2 talks after this, one by Sina to talk about code merkleization, and one by Alexi to talk about TurboGeth and other sweet, awesome magic stuff. But at a high level, we are going to make changes at the EVM level to account for the gas costs of witness generation and transmission. We are going to include witnesses in sort of like the core consensus protocol, which objectively means something like putting a hash of it in the header. And we are going to be looking at the data network as a whole, because the data network is going to have to serve kind of like a very different type of need and demand. Like today, you just work under the assumption that everybody else is a full node. And it works because that assumption generally holds true. As we open the gates up to stateless clients, the kind of like behavior of nodes on the network and the usage changes. And so we have to really address that. And I'll point out that I've included things like phones and browsers and Raspberry Pis in sort of the network level, because one of the things that we can get out of this is like broader inclusion. And I will talk about that some more here. The why. I think, is Axic in here? There he is. You walked in just in time. See? This was your question, right? Like, why are you guys doing this? Why? Okay. So you'll notice that I use the term mitigate state growth. We do not solve the unbounded state growth problem here. We just kind of figure out a way to like come at it from a different angle and say, well, let's just make the state not your problem. We'll just make it somebody else's problem. The idea here is that you kind of have the spectrum. The more stateful a client is, like the beefier the hardware and the more complex the client needs to be. The less stateful, generally lighter hardware and less complex piece of software. And so the idea here is that let's fix this from a different angle. We can still fix the fundamental problem at some point if we can get there and figure out a good way to do it. But for now, this is a way to at least push the problem a decent way out, if not actually make it not a problem anymore. Another thing is that it gives us a path towards migrating to ETH2 or ETH2 land. We do not actually include the migration to ETH2 in our roadmap, but we know that this brings us a lot closer because ETH2 is stateless. And we really need to get ETH1 there if it's going to really be part of that network. So we get closer to ETH2 and get a lot, it's a lot more reasonable to expect the ETH2 migration to be easier in a stateless paradigm. This is my favorite, better client UX. Today, who has a node that's synced right now? That's okay, but it's not half the room even. I don't. Running a node sucks. It takes up a ton of resources on your machine. It takes a big machine to run it, all of these things. And if you turn it off for a day, you have to wait a while for it to catch up, and that's hard. If you are just getting started, you might have to wait a whole day or so for it to totally sync. In the stateless model, you, with a bunch of sort of asterisks here, but you can download the client, run it, and as soon as you have your first peer connection, have a fully functional node, and that is a powerful UX change. It opens up a whole different set of use cases rather than this piece of software that you have to maintain as infrastructure, and it's hard and whatever. We see this as a way to open up the gates for more and different types of clients. When client complexity is high, we don't see a lot of clients. We've lived in the Geth and Parody show for a long time, and now we live in sort of the Geth show. And that sucks. I've been trying to put a client on the network for 3 years now, and we're only just getting to the point where we are right at the okay, we're there. We're almost on the network. It's hard. Geth is full of optimizations that make it work, and it takes a long time to build up that software. And so by making it easier to write a client, and by making clients less complex to write, we can get more of them written and on the network and let people try things out. Similarly, if it is hard to run a client, less people do it. If it is easier to run a client, more people do it. So we can get bigger and better network participation under this model if the hardware requirements for participating in the network are lower. Also, we can get rid of the one-size-fits-all model. Right now, you have one choice, the full node, and that is your choice. However, there's a lot of use cases, and we can have clients that are really well tailored for these people. And this is just drumming home that point of opening the floodgates for more clients to join the network. We want more people to come in. We want more clients participating. We want more types of clients. I want to open it up so that browsers can participate as first-class citizens in our network. This is a stretch goal. We are not committing to doing this. This is my version of the world. This weekend, we're going to work on accumulating a shared version of the world. But I believe that this is a very tangible and realistic goal for us to do. Imagine being able to put MetaMask on the network as a first-class citizen. That's 1 million nodes that can come online and help out with this network. It's a really big deal. All right, win. This is a mediocre timeline. Right now we have 3 clients who are actively working on BeamSync. BeamSync is a version of a stateless client that eventually becomes a full client. That second part is very important right now. Very soon we will have a definition of how we can talk about witnesses, and that will let us start passing witnesses around to make BeamSync work better and start experimenting with witnesses in the wild. As a whole, the research effort should be done with the kind of research and figuring things out problem by the end of this year. And we expect the overall implementation and rollout to take around a year. These are rough roadmaps. This will be refined as we go. There's a hard fork hiding in here somewhere as we make some of these fundamental consensus level protocol changes. Maybe more than one. We'll see. Okay. I've covered the like who, what, when, where, why thing. And when I gave this talk last, it was very clear that I missed a giant point. Because all of the questions, if you've been following along and you're really paying attention and you already knew some of this stuff, you might see or have the question, so where does the data come from? How do we actually support this? How can we possibly make a network in which all of these clients need data? How does it not crush the full nodes under their load? We are thinking about this. This is what it's like to be a full node. You can imagine like piling 100 more tiny piglets onto this full node, and if that's what every full node just has, like, 100 piglets like vying for a teat, then the pigs go on strike. The natural self-preserving behavior here is to be selfish with your data. That like if you are being crushed under the load of all of these people demanding things from you, eventually you shut your doors and you like hide yourself from the mob of demanding piglets. So I've been referring to this as the data retrieval problem. You have all of these, new nodes on the network that need state. And I'm going to kind of like, forgive me if some of this seems pedantic, but like there's important concepts here. So we can think about the network in terms of capacity and demand. The green nodes provide capacity. The syncing nodes are like kind of the source of the demand. There's a bit of an oversimplification here, but the overall point holds. The one important part is that the syncing nodes eventually sync and become part of the capacity. This is the node we live in today. This is the world we live in today. Which is great, because even in a situation in which the demand outpaces capacity, eventually these guys move over. And while the network may like bog down and slow down for a while, in today's world, eventually the capacity fills up and eventually everybody gets served and gets what they need. If we introduce stateless clients to this, which I will point out you can do on the network today, you end up with the same sort of balance, except for the pink nodes never cross over. They never become full nodes, so they never become part of the capacity, which means that there's always a tipping point in which if you add enough stateless nodes, the thing tips and it never untips. And I'll point out that it isn't just the stateless nodes that suffer in this world. The stateless nodes can't get the data that they need, and they generally kind of stop working. The syncing nodes can't get the data that they need to become full nodes, and so they can't transition over into becoming capacity. And the full nodes get crushed by baby piglets. And that's just like, it's bad for everybody. It's not just bad for the stateless guys. It's cool. So like we're in a good spot right now. And we could end up in a very bad spot and maybe even never recover or something like that. So I'll point out that the network has this problem today. So we have ideas on how to fix this. I have them divided into two categories. The first one here is the one that like we kind of know this. If you can increase the efficiency of the protocol that these nodes are using to transmit the data, you can effectively move the fulcrum of the lever over, which means that you need less full nodes to supply the overall demand. This is like a thing that we can do on the network today. This is an effect of the most concrete parts of our roadmap. Witnesses are a version of this. Right now, if you make a stateless client on the network, it is horribly inefficient. It issues a ton of get node data requests and things like that. And it's heavy on the full nodes. But if we can like move that fulcrum over and increase the efficiency, then we can at least support more demand with fewer full nodes, and that gets us some runway at least. My preference is to eliminate the asymmetry in the network entirely. And I think the best way to think about this is that today, for you to be a valuable network participant, you must be a full node or like very close. But for simplification purposes, you must become a full node in order to be a valuable network participant and to provide on the capacity side. If we can lower the bar to entry for providing and helping with the network low enough, then everybody can help out. And we end up with sort of a more BitTorrent style situation where even the people who don't have very much can still assist everybody else. This is not an utterly, I'm making no claims of the simplicity of this problem, but in my opinion, this is where we need to go to achieve a network that can support millions or billions of devices. It's not to say that we have to go here now or immediately, but in the other model, it still always tips eventually. And because stateless clients are that much lighter and have such a better UX and all of these like really nice things, it is not unreasonable to expect them to outnumber the full nodes by heaps and bounds. And so I would love to get to this solution where we address this problem at its kind of like fundamental core layer. How many of you in here work on this stuff full time? All right, that's like a third of the room. Cool. And by this stuff, I mean like Ethereum ecosystem stuff. Is there? All right. Okay. Then my pitch is boring and useless because you're already doing this crap and maybe getting paid for it. I love being part of Core Protocol because I love open source and doing the like, I don't know. It's like I don't like getting caught up in product land. And like I'm glad that there are people doing product land stuff, but like I don't have the stomach for it. And like this is what's the most powerful lever I have to move the world, and I like doing it a lot. But this whole effort is not constrained to any specific organization or people or skill set. So if you want to be part of the like largest overhaul to the Ethereum network that we will have done to date, come join us, talk to me, join a call, open a pull request, just do shit. I don't know. That's what I got. Questions?
Just wait for.
When you have a question, wait for the mic.
I guess like a natural question for the expectation that there will be lots of these light clients. I guess similar questions were raised on the Bitcoin side a long time ago. That do these light clients actually validate, right? I mean, the underlying reason for consensus is the double spend protection and so on. So if you only have these witnesses and you can see that, okay, so this transaction was okay, that I was interested in. Mm-hmm. But if these light clients don't actually do the work of validating all the other transactions as well.
Our current model is that there is no difference in terms of validation between a stateless client and a full node that's holding the whole state. They're doing the same level of block verification as a full node.
So I was curious if you're familiar with the light client work that the MetaMask team was doing like a year ago, and exactly, if that's like relevant or like the same thing.
Yes and yes. I had a talk with Dimitri yesterday. I like had this like data, this sort of like remove the asymmetry idea, and I've got a thing building in my head, and I've just been writing it down. And when I talked to him, he was like, "Yep, that's what we were working on." So yes, I've been talking to him and planning to pick his brain because I'm sure he's already gone down the rabbit holes and can help me avoid some of them. So yes, it's. I haven't, but MetaMask is on my like I need to talk to you guys list.
I just wanted to say that that piglet on the picture, it's not actually in my belief, the picture should be slightly different. So you remember that picture with the piglets and the pig? Well, in my belief, the situation is actually very different there. Imagine one piglet and 10 pigs. And in order to satiate one little piglet, you have to provide them the access to 10 pigs. And this is actually what's happening. So you need many more that are on the full nodes to satisfy one. So basically, even if you have half, it's already not working. I don't know how to depict it with the pigs, but yeah.
What he's basically... The picture implies that a single node can sync off of a single pig, and the idea here is that in order to sync today in the network, you actually need to be distributing your requests across multiple nodes in order to saturate your incoming bandwidth. Although each of those nodes may have their outgoing like state reads fully saturated. So you actually have to distribute your requests in order to like fully sync at the highest speed.
Yeah, can you just highlight the difference between a light client now and a stateless client we're going towards?
Yes. Okay, so we have the LES network today. I didn't mention that. There's a bunch of complicated stuff we can get into about like why it isn't reliable or if it's reliable or all of these things. We're not using the term light to talk about this, but in my understanding of where we're going and my version of where we're going, this supplants the need for a light network by allowing extremely light full clients that are equally as functional, and also equally as light, but just via a different mechanism. And in my opinion, a better mechanism because they are still doing full block validation. They could choose not to, and at which point you have an even lighter client, but that's the general idea.
So just following up on that question, does that mean that once you have a client that submits all the transactions together with the state change witnesses, and you can download everything with the witnesses that they belong to the blockchain, actually the white LES is obsolete?
I believe that this has the capability of making LES, like, what's the point? There's probably still a use case for that. Like, it doesn't preclude the option of LES, but I don't see the motivation to continue there if you can do everything that you can do under this model on the same network without needing a benevolent provider of your data, which is what LES requires, a benevolent provider of data.
How will the transition from statefulness to stateless look like?
It'll probably begin sort of in the experimental background with clients like right now Trinity, Besu, Nethermind are all like working on a BeamSync implementation. And BeamSync is a stateless client. And so we'll be like experimenting with this stuff, but in a context where like it's trivial if you want to knock us off the network by building a block that touches a ton of state that's like massive when we like make a witness. So the work that we're doing over the next year and a half is to get those efficiency gains to drop the witness sizes down. And so there'll be stuff rolling out along the way, because we, the beam syncing like clients who want to get on the network and do a better job of it, will be we'll be the like first adopters of that stuff and like using it in a production environment. The things that we can't do on our own are the forks and things. So like it'll be easy to lie to us about witnesses or to give us a bloated witness for a while until we get a witness hash in the header. And that's something that's going to take like formalizing and making sure that we have the right concept before we bake it into the protocol. Similarly, even once we probably can't put a witness in the header until we have a good, well understood economic bounds to the witness size. And so having a direct tie between gas limit and maximum witness size is sort of a requirement to know that attackers can't blast the network with a giant witness, because we want a stateless client to be able to know that they can get on the network and stay on the network and not get kicked off by like a rogue giant witness. Even if it costs, that attack costs money, you still have to fill a block with like broad state access, but it's still not something that we like can accept as a like status quo, whatever.
I have a question about in a world where it's very easy to spin a validating thin client. Is there once we have a stateless clients which are very easy to spin and they are validating, could be any problems with a big number of malicious clients doing something on the network?
Yes, but it's kind of no different than today. Like, you can make a stateless client on the network today. If somebody wants to take down the ETH network, like you can do it today with a decent bit of work. It's not like trivial because you still have to write the code like get you on the network. But like the network has this problem today of too many leechers and the network falls over, and no solid heuristic for being able to differentiate between syncing nodes and somebody who's just like sucking up capacity to be a jerk.
What about the validation part of the transactions?
That's already happened before. Like the stateless nodes are just following along. Like the miner is already like made the block, and there's nothing stateless happening there.
What is the computational overhead for generating such a witness, and will miner have an incentive to create simple blocks in order just to create an easy witness?
I love this question. Okay, so you pretty much already do 99% of the work to make a witness when you run a block, because the difference between that and making a witness is just keeping track of everything that was touched. And so the overhead to generating a witness is small compared to today. And so we can make this compulsory by putting a hash of it in the header, which means miners have to generate it. And then the next question is, okay, they could generate it, but why would they transmit it? Executing a block against your local state database versus executing a block against a witness, the witness is going to be way faster because you're reading from memory rather than reading from disk. And blocks are less likely to get uncled the faster they propagate around a network. And so by sending witnesses out with your block, you make it easier to validate them, and thus, in theory, they should propagate around the network faster. And even if a miner didn't send the witness with it, any other full node in the network who validates it also does the work needed to generate the witness and has to do it to verify it. And they can just start that propagation as it gossips out. And then the next part of that question was incentives for miners to make smaller witnesses. And we're looking at including in the gas incentive, giving miners some part of the, like in theory, if you make a block that touches the same piece of state over and over and over and over and over again, it can use a lot of gas and make a tiny witness, right? And that's like the best case scenario for a miner. They get a tiny witness, full gas usage. And the idea is that if we can give the miner some of the overlap there for like, you know, in theory, somebody might pay a little bit for each of those like witness inclusions, except for it's already there. So we are looking at giving the miner some of that extra as a financial incentive to making the witnesses with the largest overlap. Alrighty, going
Anyone?
once.
Okay. Yes.
Yeah, I guess I know the answer, but I want to hear it out loud. So how would this affect the dApp developers?
There is going to be some form of change to the gas schedule. I think it's very likely that it's a backwards incompatible change, but only maybe in the same ways that we've made other backwards incompatible like minor tweaks to the gas schedule. But overall, this makes no change to the smart contract coding paradigm, and it really only affects like smart contract or dApp developer if they're doing fancy gas things, which is, it's not that nobody does that, but it isn't utterly like ubiquitous. So it likely has a very, very small effect on existing dApps and app developers.
Could there be any positive effects for dApp developers?
I mean, if you have to host infrastructure for your dApp, today you generally have to host like the full JSON RPC interface and run like full nodes. But if all that your dApp needs is like specific state access, in this model you can have a node that only has the state that your dApp needs, which lightens your infrastructure costs and things like that. You can really, that applies to individuals as well. You can run a node that just tracks your addresses and the like contracts that you interact with so that your footprint on your hard drive is way smaller. And in general, it makes it easier just to pop onto the network and off. And so if you're doing things like live testing or whatever, you don't have to like maintain a development node that you can interact with. You can do your coding and then turn your node on and then talk to the network and turn it back off, and that's fine.
Just to make sure, the fork that would be required from what we know now, would the only things I have heard so far are there's going to be a witness in the header and some gas schedule changes, right? Or is there anything else that we would have to include in that fork?
Anybody? Oh, yeah. We're going to turn the tree from a hexary tree to a binary tree. I don't think I ever mentioned that. I did? All right. Yeah, and that's like it's a non-trivial thing to do, but it's a good thing, and it's pretty objectively, like, I don't know. I haven't heard anybody argue against it. Please feel free to if you, not now, we'll talk after. That wasn't words, I was just. It'll help ETH2. Yeah, like if we're doing like the bridged approach or anything, proofs get smaller in the binary tree approach. Like there's a bunch of kind of like ancillary trickle down things that just get nicer with that change.
Okay, thank you very much.
I'm gonna like bolt out the door and then you can talk to me there.